This is video lecture for week 13, part 2. After studying the definite integrals, now we study the two important fundamental theorem of calculus. The first, the fundamental theorem of calculus, part 1. If f is continuous in IB and capital Fx is any antiderivative of small fx, then a to b small fx dx is capital Fb minus capital Fa. Means the antiderivative of capital F is the antiderivative of f, therefore the integration of small f is capital F. Then we assign the values a to b, that is the limits. Then we put x is equal to b first minus x is equal to a. We have this. And note that this is a number always. So, using this fundamental theorem, let us solve this, that is integration 0 to 2 x square minus 2x dx. 0 to 2 x square minus 2x. So, x square is x cubed by 3. 2 out, integration of x is x square by 2. So, 2 cancels. We have this. Then this is the antiderivative, that is the capital F. This is the small f. Then I assign 0 to 2, here a to b. Then I put x is equal to 2, that is 2 cube 8 by 3 minus 2 square 4 minus x is equal to 0, it is 0, x is equal to 0, it is 0. So 8 by 3 minus 4 gives me minus 4 by 3. And this is another example computing definite integral from 1 to 4 root x minus 1 upon x square dx. So this power of x is half. So half plus 1 by divided by half plus 1, that is x raised to 3 by 2. 3 by 2, I bring it up, it becomes 2 by 3. Then x to the power minus 2 plus 1 divided by minus 2 plus 1, it is minus, minus into minus, it is plus, x to the power minus 1. Then limit 1 to 4. So I put x is equal to 4, that is 2 by 3, 4 raised to 3 by 2 plus 4 raised to minus 1. Then I put x is equal to 1, it is 2 by 3 into 1 plus 1. Subtracting these two, you get this. So the fundamental theorem is also used to compute the area, that is find the area under the curve this on the interval 0 to 5. So the area will be 0 to 5, that is a to b sin x dx. So sin x dx. So f of that is antiderivative of this. So derivative of integration of sine is cosine. So then I put x is equal to pi, see, minus cos pi. So that is the integration of sine is minus cos pi minus of cos 0, that is this. So minus of cos pi is minus 1. We have a minus here again. Then minus of cos 0 is minus 1. Then minus into minus plus, minus into minus plus. So 1 plus 1 equal to 2. Then a definite integral involving the exponential, you see 0 to 4 e to the power minus 2x dx. So the integration of this is e raised to minus 2x divided by minus 2, and that's what. And then 0 to 4, I put x is equal to 4, we have this, x is equal to 0, we have this, then this we subtract, we get this. Then we have a definite integral involving the logarithm, you see, minus 3 to minus 1, 2 by x dx, and we just apply here. And don't forget, usually we must write when integration of 1 by x dx is ln of modulus. So if you don't write modulus, then you will get a wrong answer here. So therefore, the integration of 1 by x dx is ln the modulus. Then I put x is equal to minus 1 and x is equal to minus 3, ln of minus 1, ln of minus 1. So the modulus makes all the values positive. Therefore, ln of minus 1 is ln 1, ln of minus 3 is ln 3. Then it is this. So if you don't use the modulus sign, then you get wrong answer here. So be careful that don't leave off the absolute value whenever you are integrating 1 by x dx. So a definite integral with variable upper limit. See that we have no number here, that is a variable upper limit here, 1 to x 12 t phi dt, 1 to x. So 12 out, the integration of t phi is t6 by 6, then 1 to x, and then I just substitute t equal to x and then t equal to 1, you get this answer. We have another now, the fundamental theorem of calculus, that is the second part, that is the second fundamental theorem of calculus. If f is continuous on AB and capital Fx is a raised to x ft dt, then capital f prime x is fx. So what this theorem says that every continuous function f has an antiderivative which is a raised to x ft dt. An example for that, for capital Fx, that is 1 to x t square minus 2t plus 3 dt, compute f prime x, that is capital F prime x. So what you are going to take? You take the integrand, that is ft equal to this. Then by this theorem, just replace t by x, that is f prime x, that is fx is x square minus 2x plus 3. So that is f prime x is the function in the integrand with respect to t replaced by x. Just replace t by x, you get the answer. Another example, very important, that using the chain rule and the fundamental theorem, that is if fx is 2 raised to 2 to x square cos t dt, then compute f prime x. So since here we have x square which is not just x, so I need to use the chain rule. So I assume that ux is equal to x square, that is I just change this variable x to u. Then this function I will write fx as 2 to ux in the form of u and cos t dt. Then f prime x is cos of ux, that is this t is replaced by ux into du by dx. This is what the chain rule we are using here. If so, cos ux as it is du, that means derivative of x square is 2x. So f prime x is 2x cos x square. So this ux I am just replacing back there. In the same way, another example, an integral with variable upper and lower limit. You see that I am in our earlier example, we take only the upper limit variable. Now here both are variable, lower as well as upper. So what we do here is we just split this integral as 2x to 0, the function, 0 to x square is the function, that you are replacing 0 and 0 here. And I will interchange this, so there will be minus. So 2x to 0 means 0 to 2x means minus. I have this, and this is your f prime x. This is also f prime x. You see f prime x, what I am writing here is minus, don't forget this minus. So minus square root of t, you replace by x square here, you replace by 2x, then it is t square plus 1 become 2x square plus 1, gravity of 2x. For this you replace t by x square and find the multiply by what you call derivative of x square. So this is 2 and this is 2x. So this is another example where you are computing the distance. Suppose that the velocity of a skydriver is given by this. For first 5 seconds of a jump, compute the distance fallen. So the distance fallen is integration 0 to 5, then integration of what you call the velocity with respect to this. I want distance, so therefore I have to integrate velocity. I will get the distance. So the limits I substitute. So I put t equal to 5 and then t equal to 0. We have this, and this is the answer. The last example, suppose that the water flows in and out of a storage tank. The net rate means the rate in minus the rate out, that is the rate in, is given by this. For 0 to 3, determine when the water level is increasing and when the water is decreasing. So you see, we have a W2 is the number of gallons in the tank, and W prime T is f of t, that is we have a what you call the rate. Then this will be has to be negative because it is decreasing. Then when it is decreasing, it should be t should be less than 1, then only it is negative. And since you are starting from 0, so it is 0 to 1. Then if the water level is increases, then it is positive. Then when it is positive, then t must be less than t must be greater than 1. And since the limit is 3, so it is between 1 to 3. For the second part, if the tank has 200 gallons of water at t equal to 0, determine how many gallons are in the tank for t equal to 3 minutes. You see, 0 to 3, w prime t dt, 0 to 3, and this value here. So we integrate both the sides. The integration of w prime is w. So I substitute upper limit minus lower limit, and this we integrate, we have this. Then w of 0 is given here 200, I substitute, so w3 minus this, and this is gives me this. So w3 is equal to, I transfer this, we have this. So this is an example of what you call application of definite integral here. So these are the examples. So use part 1 of the fundamental theorem, that is first law of fundamental theorem of calculus. Solve this and find the given area for these questions, and find the derivative of f prime x for this, that is the variable upper limit, and these are all both the variable, that is lower and upper. And in this case, you are asked to find the position function. Velocity is given, integrate 2 once. Acceleration is given, integrate 2 times. And this is the example which just now I have done, the 37 and 38. So more examples of these, we will solve it in the live class. So these are the answers, check. And what we studied in week number 13 is, what do you mean by definite integral? What is the difference between indefinite and definite integral? And 2 fundamental theorems of calculus. So that's the end of the week 13 second part, and we will continue next week, the 14th, what you call week number 14 lecture, video lecture. Thank you one and all. So with more detail we will take up in the live class. Thank you all.